Hello class, this is lesson 1.3, linear functions and slopes. So, a linear function is a function that can be written in the form f of x equals mx plus b. Okay, and m and b are constant numbers. We call m the slope, and b is a number we learned before. It's the y-intercept. That is, if you set x to 0 and solve for y, or here we were using an f instead of a y, but that's okay. You could say y equals f of x equals mx plus b. Anyways, b is the y-intercept. Okay, so I'm sure you've seen this equation before, the mx plus b equation. These are represented by lines on the xy plane. So if you have an xy plane, it may look like this, or it could go like that. Right, so that is what the graphs of these linear functions look like. Now let me give you two special cases when the line is going straight up and down, or when the line is going horizontal. So straight up and down we call vertical. Right, so say we have an xy plane, and then here in blue I'll draw a vertical line. For a line like this, we have the equation x equals some number. Say this value here on the x-axis is the number a. Notice how for any y value, x is always the same number. So this equation here describes a vertical line. Okay, another special case is the horizontal line. Right, so that's when we have a line that looks something like this. Let's say it crosses the x-axis at some b. You may have guessed the equation for this is just y equals number b, because for any x value, right, it does not matter which x value we pick, y is always equal to b. Okay, now let me now discuss the slope in a little more detail. So we are looking at formulas like this: mx plus b. M is a slope. You could think of m as rise over run, and I'll explain what I mean by that. It could be thought of as a change in y over the change in x. And algebraically, it could be written like this, say y2 minus y1, or x2 minus x1, where let me give you a picture to define what y1 and y2 and x1 and x2 are. It's just if we have a point x1, x2, x1, y1, and say we have x2, y2 over here. So connect the dots with a line. The length of this is the change in y. It's the change in y, and it's given by y2 minus y1. The length of this is the change in x, and it's given by x2 minus x1. This could also be thought of as the run, and this is the rise. So when we say rise over run, we're just saying how much we change in y divided by how much we change in x. Okay, so let me demonstrate with some numbers here. Let's look at y equals 3 over 2x, and then I'll just do plus 0. So we'll start out easy where the b value is 0. We'll start out easy. Okay, so rise over run here is 3 over 2. So we change 3 in y, 2 in x. If we have an xy plane here, since b was 0, we cross the y-axis at 0. And now we go up 3 over 2. Up 3 over 2. Okay, so you see the change in y is 3, change in x is 2. Our slope is 3 over 2. Sorry, I drew kind of a sloppy line. It should go through the 2 points. Okay, so here we were given a slope and we plotted it. We could also go in the other direction where we are given a plot and then we find an equation. So let me draw a graph here. Okay. So we have this graph here. And we want to find the equation for this graph. Okay, well, if we look at this graph, we can see the y-intercept is the number 1. We could see that the rise over run is, well, from here we go up 3 over 3. Right, we go up 3, so here's the number 2, here's the number 3, 4, and we go 1, 2, 3, so we go up 3 over 3. So our slope is 3 over 3. The slope is 1. Okay, so now we plug into the mx plus b, giving us y equals 1 times x plus 1, or simply we could say y equals x plus 1. Okay, not too bad. Let's look at a few more examples now. Well, let me go back. I want to say a little more on these examples. Here, on a horizontal line, the slope is 0 because rise over run is sort of like 0, and I don't know how you want to think about it, over infinity if you want. Maybe not the best way, but the point is we're rising 0 and over any amount of run. So if you rise 0, run 1, 0 divided by 1, 0. Okay. Let's think about the slope here now. We can rise up to infinity and run 0, right? This one's a little more tricky, sort of like the slope is infinity, but what we're going to say is that the slope is undefined. Okay, so in these special cases, when it's the straight up line or the horizontal line, we have the undefined slope and the slope of 0. Okay? Anyways, let me keep doing some more examples now. Let me let's try this. Let's say 3y plus 2x equals 4. Graph this line. Well, you'll notice this is not in the y equals mx plus b form, but that's okay. We can just move a few terms around until it is in the y equals mx plus b form. So what we have here is 3y plus 2x equals 4. So I could write this as 3y equals negative 2x plus 4, right, if I just minus 2x to both sides of the equation. Okay, now if I divide everything by 3, we end up with y equals negative 2 over 3x plus 4 over 3. So here is m, and here is b. Now if we were to graph this, we go and find b, 4/3. Okay, now look at this. We have a negative slope. So what does that mean? Well, we could think about that as we go down 2 over 3. So we'll go down 2 over 3. Okay, so what's 4/3 minus 2? Right, we got to figure that out because we started at 4/3 and we went down 2 units. Okay, well remember, if we minus fractions, we need the same number on the bottom for both terms. So here, the number 2, I need to rewrite it so that it has a 3 on the bottom, or I could write it like this. If I multiply a 3 to the top and bottom of this term, it does not change the value, right? 6 divided by 3 is equal to 2. Okay, so now this becomes 4/3 minus 6/3, which is equivalent to 4/3 minus 2. But now that we have the same thing on the bottom, we can combine them as 4 minus 6 all over 3. right? Or minus 6, negative 2. Okay, so this number here is negative 2/3. Okay, so the 2 points we found on the line, we have 3, negative 2/3 for this dot here. This dot here is when x is 0, y is 4/3. So one thing we could notice from this example is if we were just given points, could we work backwards and find the equation? So in this example, we were given the equation, and we found m, we found b, and we plotted 2 points and drew a line. Let's now do a problem where we go backwards. We're given 2 points, and we work backwards in this direction. Okay, so I'll do that next. Okay, well, before I begin, let me go back and show you the idea we will use here. We can use this idea. Right, so if we're given 2 points, say these are the 2 points, we can find the slope. And we can find the slope like this. Okay, so let me do an example here. We'll start by just finding the slope, and then later we can find a equation for a line when we are given 2 points. But we'll start a little easier, and we'll say find the slope of the line that passes through go with 3, negative 1, and 3, negative 4. So using the formula we had, which was the change in y for the change in x, we have the following. We do, we'll call this y2, y1, so x1, sorry, y2, y1, x2, x1. So we'll do 3, oops, sorry about that. Do y2, so minus 4, minus negative 1, over 3, minus 3. Okay. Now, we just did y2 minus y1, x2 minus x1. This maybe wasn't the best example to start with first, because look what happens here. We get on the top negative 3, but on the bottom is 0. That's undefined. So what happened here was we were in this special case where we had the undefined slope. And you could see that by looking at the 2 points we were given, because notice how x did not change. So we were given 2 points that were on the same vertical line, right? I guess they were down here. So this was a vertical line. So if we wish to even go one step further, than finding the slope, we can actually find the equation for this line. That's just x equals 3. Right, we have this equation, x equals 3, and we put a vertical line through x equals 3. Now the 2 points we were given were this point and this point. So these are the 2 points we were given. Okay, let's try another example. Find the slope of the line passes through 3/8, -1/2, and 1/4, 1/4. Okay, by our formula we do 1/4 minus -1/2, 1/4 minus 3/8. Okay, so a lot of fractions here. Let's just start with the top. Alright, so we don't get overwhelmed, I'll just leave the bottom alone for this step. And we'll focus on the top. We have 1/4 plus 1/2, right? But 1/2 can be written as 2/4, right? If we multiply a 2 to the top and bottom of 1/2, then we have a common denominator now. Right, so now we will have 2/4. And I think you will agree with me that 2/4 is the same as 1/2. We have a plus sign here because of the double negative. Okay, so again, I'm just doing the top here. We'll do the bottom later. So the bottom is 1/4 minus 3/8. Okay, so now let's do the top. 1/4 plus 2/4 is 3/4. Okay, now time for the bottom. Well, we need a common denominator, so I'm going to have to multiply an 8. Let me clean this up, it was a little sloppy. We have 1/4 minus 3/8. Now, I need a common denominator, so I'm going to multiply 2 to the top and bottom here. Okay. And now we have 3/4 on the top. Now when we do 1/4, 2 multiplied to the top and bottom, we get 2/8 minus 3/8. Okay. So the top is 3/4. And now 2 minus 3 is, of course, -1. Okay, so a fraction on top, fraction on bottom. How do we handle this? The fraction on top is 3/4. Now, division by a fraction is the same as multiplying by the reciprocal of the fraction. And let me say that again. If we divide by a fraction, that is equivalent to multiplying by the reciprocal of that fraction. Right, so this step is allowed here. We changed it into a multiplication problem. Okay, so now on the top we have 3 times -8. On the bottom we have 4 times 1. Okay, well, I'm just going to simplify this a little bit. I'll bring the minus sign out front. And I'll notice that 8 divided by 4 is 2. So we have negative 6. The slope here is negative 6. Okay. So a lot of fractions there, but it's not too bad. Okay, let's see, I think I'll end there. I know I said I'll do an example where we find the equation for a line when we're given 2 points, but actually you won't see anything like that in the homework. You're just going to be asked to find the slope, so maybe I will just leave it there for now. We're going to be doing more graphing in the future, but for this section, this is all we need to know. So a quick recap of this lesson. We introduced the mx plus b equation. M is the slope, b is the y-intercept. We have these two special cases where it's vertical, undefined slope, horizontal, slope of 0. We can find the slope if we're given 2 points by this formula here. And then just did a few examples using those formulas. Okay, thank you for watching.